Thank you. And thank you all for being here. It's so fun to get to meet new people in the community and learn new things, or maybe talk about the things that we all kind of do the same and love so much. Hopefully, my talk continues to emulate that as well. So this talk, Going Pro with POROs, one of the big motivations or impetuses for this talk is that I really have a penchant for words. I love learning new words. I love finding just the right word for a given situation. And I really believe in the power in naming things. Being able to communicate with someone and gain confidence that you are all on the same page leads to greater creativity and problem solving together. So I want to put a talk together where I could start to give some names and vocabulary to the way that I organize my code and some design patterns I've learned along the way from other developers or have simply explored or read about. I hope that maybe some of these are probably familiar to you. Maybe you have different names, or maybe you even have different patterns that I didn't touch on, and I'd really love to hear about those later if you'd like to come up and chat with me. So with that, maybe I didn't turn this on. So a little bit more about me. My name is Ifat. I work at a digital product agency called Launchpad Lab. We are headquartered out of Chicago, but we have developers from all over North and South America. This has really been such a boon for us. I've gotten to learn from so many different developers as we're very project-oriented, so getting to work with different teams at different times, learning different styles, coaching each other, exploring different patterns together has been absolutely incredible. We've also had the opportunity to solve novel problems or start to see how some of the same problems come up time and time again, and gaining some mastery around how to solve those, or maybe taking a chance on a new exploration. So one of the big themes that I want to keep in mind throughout this talk is this idea of encapsulation. And we heard a little bit about it in the last talk by Mark, which really resonated with me. This idea of being able to define the boundaries in your code. What are those domain models? What are those aspects of business logic that you'd like to encapsulate and keep in a certain place, making them easier to reason about, being able to follow some of the solid principles around them like we talked about, and things like that. You'll see that I'm going to probably bring this up quite a few times in the different patterns, because that's really all these are just different ways to encapsulate your code. The second big theme I like to keep in mind is putting an emphasis on clarity. There's so many different ways to write, particularly Ruby code. That's the beauty of it. It's flexible, and sometimes that can be a double-edged sword, but it's also mostly just a lot of fun. The idea, a good sort of guiding principle that I've used in my code is this clear for another developer? Of course, that includes you in 6 months, 12 months, 5 years down the road. Can someone looking at this, getting onboarded, or having to solve for a bug that came up unexpectedly, how easy is it for them to find the code, to reason about it, understand it, and continue to work with it? The last theme I'll keep in mind is simplicity. It can be really fun to think of clever ways to solve things. You can write really beautiful, almost esoteric code, and that's really cool to flex your skills in that domain. But again, as soon as you're working with someone else, and again, your future self is a totally different person, as I've come to find out. Keeping things simple helps reinforce those first two themes and makes it a lot easier on you and other people that you might be working with. So with that, I'm going to touch on these categories of patterns. I know what you're thinking. The first two on here aren't even POROs, but do bear with me. They are up here for a reason. I'd like to set a foundation for the concepts that we're talking about and be able to build upon the things that are likely the most familiar to many people in this room, and maybe going down the path of things that might start to be novel or different for some of you. So we'll go through database wrappers, modules, services, API wrappers, virtual domain models, and request and presentation objects. Well, let's get started with database wrappers. This should be the most familiar, I imagine, to everyone here in the room. This is just referencing classes that are usually part of an object relational mapping framework like Rails. There are others, or maybe sometimes you're rolling your own, or you're mimicking something like it. It provides a really nice interface for working directly with your database tables. Rails in particular provides such a nice DSL for making queries and not having to know a lot of SQL, or defining your relationships and associations, or working even with constraints, right, in the form of validations and some of the DSL they provide around that. So I sort of alluded to the way that they're commonly used. One sort of pattern I've converged on as I've gained more experience as a developer is that idea, and we saw this also in the last talks, this is a really good segue, but the idea of focusing on that single responsibility. Your active record, perhaps table or class in this instance, I've sort of focused on keeping that close to just what's related to the database. So really just focusing on the items that we're listing there in that bullet, things that really just make it easier for me to work with the database table. Because it can be very easy, and this was a common pattern, to start just sticking stuff into the model class, right? Oh, well, this is kind of about the user, or I need the user to do this logic, so I'll put it in the user class. But that starts to become really gnarly and maybe turn into some of that spaghetti code we've been talking about. So I've been trying to be more intentional about that and leverage some of the other patterns we'll touch on to find other places to put that domain logic where I might have reached for the table class. One thing I do want to point out, and this may be fairly obvious to a lot of people in the room, but it was such an aha moment for me when I was first starting out learning Ruby on Rails, is that the ORM is really used for any database or any table in your database on any schema. I realize that's the point and that's so obvious, but it was so mind-blowing to me to understand just how powerful an ORM is. So it is really great, but like all the tools that we've been handed, learn them and use them wisely, right? So just a couple examples to bring these to life. On the right, hopefully you can see this, I'm not in the way, is just a more standard class. I've got this workout plan table in my database, and you can see I've really limited it to some associations, a constraint where a not null constraint there. Maybe I've got some enum types defined, some queries with scopes, and then maybe one simple instance method that is actually just wrapping a slightly more complex query, essentially, right? You could argue maybe that is better placed somewhere else as well, but focusing on being intentional about keeping things close to what is actually relevant to the fact that you're working with a database table. The other example is the same thing, and just illustrating how you can work with really any schema. At Launchpad Lab, we work with a lot of clients who use Salesforce, so we do a lot of projects. We are integrating the two, often with a tool called Heroku Connect, which really powerful, phenomenal tool. But what it does when you attach it is it instantiates a Salesforce schema. So it was really incredible being able to just write some active record wrappers around that and treat it just the same as any other table in our database. So next up is we have modules. These are really fun and something I've been playing around with more and more. So really, at the end of the day, all a module is a collection of code. We talked about namespacing. That is a very common use case for modules, and that's all it's doing, right? It's just sort of bundling code together, but it's really nice in that instance because it gives you an opportunity to use a name. Probably one of my favorite PR comments to make is, can we name this thing? Can we extract this so we can give it a name, make it semantic, have something to refer to, and make it easier to read? Modules help a lot with that. A couple things to note about modules. I realize this is another one that doesn't fit into the PORO category because they cannot be instantiated. They technically are an instance of the module class, but that's a different talk. A module, when you're generally using them, they cannot be instantiated, but they're incredibly flexible, right? You can use them directly by exposing them as public methods with the self-notation or the class self-notation, which can kind of be misleading in that sense. Or you can use them sort of indirectly by including, extending, or prepending them to other classes or even other modules that you might have. So when you're first starting out, and maybe still today, wherever you are in your journey, you're probably using modules quite often. The common conventions are to see these as model concerns. Perhaps you have two different models and they have a lot of shared logic. Maybe you want to extract that into what Rails calls a concern, but it's just a module, right, that you can then include in each of those tables. Very similar fashion is the controller concerns, to keep controllers thin, as they say, but focus it on the request. Maybe the heavier logic you want to outsource, as well as view helpers. I personally love view helpers, especially when you're sort of just starting and just trying to get something to run fast, which coming from an agency, we're always trying to build fast. So view helpers, I think kind of underrated these days, but they're just a module, right? And they're loaded automatically in your view layer, and they're a really great way to extract presentation type code away from anywhere else in your business logic. And the last one I really want to point out here that I'll show an example of, and I think sort of my mentor at Launchpad, my manager, he really sort of gave me this idea and helped me shape this perspective around modules being a great way to sort of inject a type of functional programming in Ruby. Obviously, we love object-oriented programming, but functional programming in terms of its simplest sense, right? Same output for any given input, right? Repeated, very expected output and behavior. So this is really well known if you're writing a calculator. And I mean, literally calculating, like you're adding two things. Calculators are a great, they are best represented for me as modules because they don't really need to extend or enhance certain functionality, but they just need to take an input, provide an output. So a few examples of those. So the first one, right, just a model concern. A model concern is a great way to start with achieving that, maybe the goal we had from the earlier slide about keeping the actual model class a bit focused. Maybe you start extracting logic into a module, and maybe later you can use another pattern. But for example, I have these two tables, a school and an office. They both have address type fields, and I'm often presenting those fields in a readable fashion. So maybe I have simple address concerns that I can include in both model classes there. And this simply format them. They expect all the fields to be named the same, but of course you could do some clever programming with that if you'd like. So with the next example here is a controller concern that we use a lot to just help abstract away a lot of the request handling, particularly around error handling in our APIs, as well as capturing things like we use Sentry for alert monitoring, and we sort of just have that in one place so that we don't have to remember to include that into all our controllers. And of course, the famed view helper. Maybe I just want to format a date for this one model, or maybe I want to do it everywhere and I can include an application helper, and that's great. But hopefully these are likely very familiar. So maybe an example of that calculator. Maybe I have that workout model and I persist a lot of the raw data around the time it took to complete the workout, the distance covered and things like that. But perhaps I want to do some calculations and do some math, right? I want to figure out what the pace is of, perhaps I did a speed workout or a long run or something like that. So again, they just take inputs, they give outputs, it'll be the same expected behavior every time, and I can test each of these instance methods sort of on their own if I wanted, or by referencing a dummy class or something like that. One thing I did want to point out is that so in this instance, I don't use self, so I maybe would include this, but you could imagine, for example, each of these methods had self at the beginning. I've actually started to converge on that, and I probably should have made the example this way, but because this is just another opportunity to make things more discoverable in the application. We heard a little bit about that this morning as well. But if I, instead of including workout metrics in a file, and maybe I'm not calling convert speed until all the way at the bottom of the file, another developer just coming to the project, they may have a hard time figuring out where that method is coming from. I know IDs and all our tools can help us find it really easily, but from a cognitive load perspective, it would be so much easier if I could just call workout metrics, dot convert speed or something like that. Now someone knows there is a bundle of code out there representing calculations around workout metrics. So I've definitely started to lean into that pattern quite a bit more. All right, so I made a major faux pas in this presentation. I've been saying this acronym POROs several times without defining it, so I deeply apologize. Let's remedy that and fix that now. What is a PORO? A PORO is a plain old Ruby object, a moniker used to distinguish any other Ruby class from a class not backed by, or a class backed by a database table, right? So the ORM style that we talked about earlier. That's all it is. It's just a class. We're Rubyists, we love classes, we love objects. So pretty much everything you're doing with a class is probably a PORO. So let's get into it. The rest of these categories fall under the line of POROs, and we'll go through specific examples under each of them. So we'll start with services. I know there's been a lot of conversation about this term and a lot of different opinions, maybe some articles. Be curious to see the different perspectives we have here. And I'd like to share my perspective on services. And it may be on the side of hot takes, as it will, but I've decided to lean into it on the premise that I described earlier, in that I am making this a defined pattern in the way that I approach services, and I'm being more intentional about other patterns. A lot of times services sort of become this catch-all name for just any PORO that's doing business logic, but I think we can do better than that. I think we can come up with more distinct names for the types of logic we're working with and what those classes are trying to accomplish. So with that, services to me are POROs that encapsulate business logic to perform calculations, transactions, or a series of steps. Yes, procedural code. That is what I use services for. Understood that maybe using an object, instantiating a class isn't really taking the full advantage of object-oriented programming, but you can still utilize a lot of the benefits that come out of working with a class, such as convenience, the convenience methods that begin with the adder. You can expose public attributes if another object does in fact need to know something about this process that happened in your service. And you can also leverage inheritance as another way to indicate that some pieces of the code might be sort of related to one another in some way. The way that I write services, and is quite common at our agency, is to generally expose the one public method, oftentimes called run or call, or perhaps you use a verb that is about what it's doing in there. We often name the class itself after what it's trying to accomplish. I generally name it as a verb, but truly there is no right or wrong way to do this. It's just a pattern I've leaned into for consistency. And I tend to reach for adder reader a lot for the key attributes. I started using it a lot for purely convenience. I am a lazy developer for sure. And after talking with some teammates, we've kind of refocused to, again, be more intentional about what that's signaling. So adder reader is actually just making a public method for you for that attribute, and now another object sort of has information about that, and maybe you don't want that. So we've started leading to the pattern of really only using that for the attributes about the class that we might actually want to expose to other objects. So an example of that, very common example perhaps, is the idea of a factory. You simply want to execute a series of steps to create other objects. We've got this school factory here. It takes in some params, and this class is really responsible for calling school.create, but maybe we need to do some other things. Maybe we need to enroll someone. Maybe we need to dispatch some notifications and things of that sort. So you can see it's simply a series of steps. In this case, I am returning an object. I'm not exposing the params, but I'm working with them throughout. So perhaps another slightly more practical example as well. A long time ago, I really wanted to work with the Map My Run API. We'll see some more examples there. But I wanted to build an app that I could tweet out my progress during my first half marathon that I ran. So some time ago. So here I simply, I'm working with that API, so maybe I'm fetching the workout that I posted, yes, mid-run. Not sure I totally advocate for that approach, but I'd go fetch the workout that I just logged every few miles. I might sort of persist that in my own data store, and then I might go ahead and do some work with the Twitter API, either in here, or maybe you want to shelve that out to another class. But again, simply a series of steps that accomplishes some work, and that is all it's responsible for. One thing that I do expose here is the errors variable, so perhaps there is something else that wants to know if it went wrong. Maybe there's a different place I want to expose that there was an error, whether it's a monitoring tool, or maybe there's a controller for this with a UX that you want to expose though. So more intentional here about what is getting exposed. So it's a good segue into API wrappers, which some people may sort of think of as sort of being a very specific version of a couple of these other patterns, but I wanted to call this out because I think it's used very frequently. So an API wrapper is simply a reusable class to interact with external APIs, and maybe those external ones are still ones you wrote, or maybe there is a gem or an SDK for an API, but maybe you wanted to put some more custom abstractions around that for your own purposes. So a lot of times when we write these, we write interfaces for making requests to the API, and that may be as redundant as writing a get method, and all it does is call http:/party.get. But the idea there being that, well, maybe we were going to use net HTTP directly, or maybe we need to switch it out to some other paradigm. Maybe you're using SOAP or XML, and you want to sort of just write a reusable interface for how you're interacting with those APIs as a way to kind of abstract away those details. So I alluded to this. We often sort of rewrite the RESTful routes if we're working with a HTTP request. We also include sort of overwritable methods to customize different things that different endpoints might need, right? A post request might need to overwrite the payload that it's sending around, or maybe there's a token request and it needs a different header than the rest of the authorization-based requests, as well as the boilerplate or code or helpers that each of the subclasses might share together. So again, I was working with the Under Armour API some time ago. You can see examples of the things that I described here with these different wrappers. Again, there's a GET request, there's a POST request in this case, and there's also sort of these indications around what subclasses that are using this interface might need. So perhaps an endpoint is required, right? We need to know which resource we're fetching or which endpoint we're working with. We can overwrite some of those payloads there with data and headers and some other things like that. Maybe some of them are required, maybe some of them have defaults, or maybe some of them are just there and can be ignored. Kind of see that in action. I've got this activity data class. You can see it's just making that GET request from its parent class, and it's using sort of very specific endpoint. It's responsible for figuring out how to form that query. There's also sort of an after init if it needs some other data setup or things that it needs specific to this endpoint. Okay, that brings us to virtual domain models, which are really great and something I've certainly been leaning heavily into. They're really useful to, again, stay focused on that attempt to keep that model class very simple and stick to just database-focused operations. But more than that, you can represent now any sort of domain object in your application with this virtual domain model. All right. So this is simply a class that represents domain objects that aren't database-backed. These tend to be, but don't have to be, very transient. So maybe you're working with them kind of immediately in point in time, and that's why you're not persisting them in a database table. They may be passed along to other services or things that need to happen in your code. A lot of times they simply look like a class with public methods for the attributes, much like Active Record does. I've also seen a lot of people sort of rewrite CRUD actions if they want to sort of mimic Active Record and follow some similar patterns there, as well as some memoized, more expensive calculations or things that are reused, but you don't want to have to do over and over again within the instance. So a really common use case is to actually capture the results of those APIs into a virtual domain that you can work with, as well as some calculations. I actually worked on a finance application where we were basically projecting financial models, but generally these financial models work line by line item. So if you've ever seen sort of like an accounting balance sheet or something like that. But there were certain areas where certain line items actually depended both on the line before it and somehow also on the line that was going to come after it. It's a very tricky, sort of recursive sounding problem. But in fact, POROs really saved the day with a virtual domain model, representing that line item as a model with methods that could be calculated and memoized, made it easy to share those either for the level before or the level after it. Did have to watch out for sort of a singular dependency or sort of needing something before it was calculated, but it made it much easier to solve this problem. So again, with the API we just looked at, that example, maybe I want to take that the results of that fetch, and I just want to expose some very basic things about it that are deep in the payload that I receive from the API, but I want to give it my own definition and be able to describe the shape of it to the rest of the code. So in this case, it happens to know about the result hash. Maybe that's something you'd like to do earlier in your code or have something else responsible for it. But this is a pretty straightforward example of how that could come to life. And as I mentioned, I would sort of do that right after making the API call, capture the results of those, and sort of turn it into a class that I'm more familiar with. An example of that finance example that I provided, so perhaps there's a concept of debt that you need to pay off, but they need to be in order, but you might want to do some planning around when you pay off or how much you pay off certain debt, because that might affect how you manage the principal or the balance on other pieces of debt. So for instance, this PORO takes in both the previous projection and the line items that came before it. It also takes in the debt that came before it, and then it can go ahead and do some work with it. And this is very contrived. If anyone here is a finance expert, please don't test me on this. I want to make a fairly simple example here where you can see towards the bottom there, it's actually leveraging that superior debt, and then something else, it's calling the interest accrued method from this pure debt PORO that was ostensibly already instantiated and calculated. So this became really helpful for that problem. And that brings us to our last category, request and presentation objects. So a lot of components we'll see in here, continue to harp on the idea of single responsibility. Let's keep code focused on exactly what it's responsible for, makes it easier to extend, test, and achieve some other code quality goals you might have. So these are the POROs that, as the name suggests, I don't think I was that clever with the names. They support the request, response, or presentation layers anywhere along the way there. I sort of lumped them all together. And they attempt to reduce controller as well as model and view complexity, right? You could easily write presentation code in your model. You could easily write data code in your view. That, as we know, can become really hard to reason about and fix and troubleshoot, and it just creates a host of problems. When you have the opportunity to extract those things to other patterns, you have a chance to name them, to document them more specifically, and definitely test them in an easier fashion. So a lot of the patterns I'll list here, a lot of them come, there are people that have written awesome libraries, maybe someone here in this room has done such a thing, but they really advocate the idea of making them easier to test. So the subcategories here are presenters. That's just a generic term. This might just be a class that you hand roll to encapsulate presentation type logic. Decorators, so there's a nice gem called Draper that does this. Draper is really nice because you call the decorate method and essentially it instantiates another version of your object with some methods that you define around how you want sort of the attributes to be presented. And it also exposes the original object. So you kind of have the best of both worlds. You can work with either of those. If you don't need to define any formatting, you can simply delegate out from the original object out to the decorated object. We also have form objects, which become really powerful with really complex forms. I personally always kind of muck around the syntax of, especially when you're working with very nested children and complex forms like that. Arguably, maybe there's a way to take a step back and think about how to make the form simpler, but form objects are one step in that direction. These would be POROs that help you just focus on the work that you need to do to set up the data for the form or manage any interdependencies, and you can write it in a way to sort of mimic what Rails sort of expects a form to do, right? You might have a save method or something like that and handle surface errors in a similar way. The last two here, serializers, primarily used for APIs to format data into the shape that a client expects. We write a lot with React and do a separate API and React architecture, so we use a lot of serializers. And this last category, I didn't really know what the name was, so I just call them transformers. This is sort of when data is incoming and you want to do some coercion into the shape that Rails or the database expects. And for example, you can imagine there's a date string coming from the JavaScript side that for whatever reason wasn't formatted the way that Rails expects. Maybe you do that coercion in a separate place, as well as maybe account for things like strong parameters and whitelisting and blacklisting parameters. So some examples of those. We've got a workout component here with the view component library. Again, just a PORO is just a class where you can define what certain aspects look like in a more presentational aspect, and then simply sort of render that component. But that component is class-based. You can simply test the class. You don't have to figure out whether the view is sort of rendering everything correctly. I have it here where I'm rendering sort of a small partial to actually render out these different formatted attributes. In a similar fashion, Draper's decorator approach, it actually looks pretty similar, right? It's just a class. Again, maybe in this instance, this convention, I've actually utilized the same names rather than sometimes in my view objects, I like to still indicate that they're views, like formatted or display. But with decorator, I tend to reach for the same name so that it actually knows that you're kind of trying to mimic the same object. It just has this presentational approach. So you simply call decorate in your action, and then the variable that's exposed to the view is that decorated version. But like I said, you could always just delegate or reach for the raw object if you need it. So this would be an example of how you might use a form object to work with a slightly more complicated form. For instance, this is a bit simpler, but say there's two-factor authorization and you get to choose which one. So there's some conditional logic here. Whether you provided an email or you provided a phone number indicating you'd like to receive the code by text message, this class can kind of handle that. We leverage active model and its validation, so we can, again, use a lot of the patterns that Active Record provides and we're very familiar with, but we can sort of focus on just what's important. We can do some formatting before validation so we don't run into some unexpected errors, and we can kind of just define the logic that needs to happen. So for example, if I chose email, then I needed to go do a bunch of other things. Maybe the next page of the form is different, or maybe certain validations are different. I need to handle those errors. Likewise with the SMS approach. Or maybe there's a catch-all sort of errors that I'd like to add to the base object around completing the form at all, right? That is totally possible that a user will just go on and try to continue. So these form objects are a really nice way because now we can just test the object itself and not worry so much about the complex layer of the code. So here we might instantiate that object. Again, these are very contrived actions. I realize that they're not very RESTful routes, which is also a separate talk. But you can then use that form again, bring in the params, and perform that logic, and do some things with that, and then simply call the form there up in the form with, and now you have this form object to work with. This has been a really nice pattern that we've definitely been taking advantage of more and more as forms do get more complex and people expect to be able to provide a lot more information right away, but from a data perspective, those might be a lot more parsed out, and you want to balance that user experience with the needs of your database. So just a few more small examples. The serializer, right? Maybe some of you are familiar with. You're writing a lot of APIs. We a lot of times reach for fast JSON API with a couple of helpers that we write. But again, it's just defining what the shape of that object is for the client to handle it. And you'd render that as JSON. And then that would be for outbound data. Coming in for inbound data for these transformers. This is a shameless plug. This is an open source library that we wrote called Decanter. Essentially does combine strong params with the idea of coercion. So for example, you can define that certain inputs are going to come in and be allowed, and you might want to tell it exactly how those inputs, what data types they should be. Maybe the distance is coming in as a string, but you'd like to make sure that it's an integer before the database sees it. And maybe you also want to ignore certain parameters, either not allow them because they just shouldn't be or because they were actually presentational, but your client sent them back anyway. You can ignore those. And there's a lot of other cool functionality that this gem provides. Happy to talk more about it. I think it's pretty neat. But you would simply call it in your controller with decant there with the params, and it'll make sure that they look in the shape that you expect when you're ready to persist that object. So that is it. Those were all the patterns. I hope some of this resonated with you or maybe inspired some perspectives of your own. I would love to hear it if you'd like to come up with that and share some more with me. So thank you very much.